In this video, we're going to learn about logic and truth tables and the ifs function within Google Spreadsheets. This is probably one of the most useful things you can do in Google Spreadsheets or Excel, just because of the logic that's involved with it. You can do lots of great data manipulation using these functions. So this will be split up into two parts. The if function is the first one I want to talk about. So let's get started here. If there's a function called if within this program. So if you type in equals if, it asks you for a few things. Basically, it's asking if this logical expression you choose is true, then you want to display one set of values. Otherwise, if it's false, display another set of values. So let me show you what I mean. Let's say we have some clientele and they are between the ages of, let's say, 45 and 80 years old. So let's pick a random number between 45 and 80. Let me drag this down. And you can see right here that these numbers are just basically a random number between 45 and 80. And we want to say, we want to use an if function to determine if somebody is older than, say, 65 years old. Now the problem with these numbers is they constantly regenerate every time you type something new in here. Notice how all the numbers just changed, because it's constantly choosing a random number. So in order to get these numbers fixed without them changing all the time, you can highlight them, press Control-C to copy, and then we're going to paste the values only. So those values now, they're stuck, they're not going to change. So every time I type something in, this row keeps changing, but this one doesn't. So I'm going to get rid of this first column. So now we have some random numbers between 45 and 80 that we can use that won't be changing. So what I want to do is make an if statement that determines whether or not the person is over 65. So I'm going to say if, open parenthesis, this number is greater than 65, make it true, else make it false. When I press enter, now this person's not over 65, so it says false. If I drag this formula down, you can spot real quickly who is over the age of 65. Now you can do this besides having the result be true and false, perhaps to determine maybe a discount. So let's say if they're over 65, they get a 10% discount. So I'm going to type in 10. Otherwise, if the statement is false, they get no discount. So the first number that comes in here after the logical statement is what if the statement is true, this is the result. The second number is if the statement is false. So only the people who are over 65 get the 10% discount. Now what if we want to have two discounts? One if they're over 55 and another if they're over 65. So let's say, for instance, if they're over 65, they get a 10% discount. Otherwise, if they're over 55, they get a 5% discount. Now the problem is there's actually three cases. One when they're over 65, when they're over 55, or when they're over 45. All right, everything kind of in between those numbers. So what we need to do is put another if statement in here. Instead of saying false, if they're not over 65, we want to check if they're over 55 before we move on. So I'm going to type in another if statement. So if they're greater than 65, they get a 10% discount. Otherwise, they're not, so it's false. So we need to check for another condition. So therefore, if this person is over 55, then they get a 5% discount. And if they're not over 65 and they're not over 55, they don't get a discount. Now notice there's a set of parentheses for this if statement. So I need to put another last parenthesis to close the first parenthesis from my first if statement. Drag it down. And now you'll notice some people don't get a discount, some people get 5, some people get 10. So this is called a nested if statement, when you have an if statement inside of another if statement. So you might be asking, if they're over 55, or sorry, if they're over 65, doesn't that make it automatically true that they're over 55, so they should get a 5% discount? But if they are over 65, it never gets the chance to check this part of the statement because it's already true that they're over 65, so the 10% discount is already given and it doesn't even bother checking the rest of it. So that's one way to use some if statements. Very, very useful. All right, now for the second part of this logic topic, I'm going to get rid of this. And the second part is about truth tables. So let's say we have a truth table where you have two possible conditions, an A and a B condition. There are 4 possible outcomes. Condition A could be true. Condition B could be true. Condition A can be true and B can be false. And the other 2 possibilities, A is false, B is true. A is false, B is false. So there's only 4 possible conditions. True, 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 false, false, true, or false, false. So sometimes you want to know if either statement is true, one or the other, then you want the outcome to be true. So that's called an OR statement. So if A or B is true, either one can be true, then the output will be true. So this is going to be called an A or B. In mathematics, they use, it looks like a V symbol for the word OR. But I don't have that symbol on here, so I can't use it. So I'm going to make in this column the output A or B. And there's a function in here called OR. So if A is true, comma, or B is true, make the output true. If A is true or B is true, well, both of them are true, so for sure the answer is going to be true. If I drag this formula down, again, you can see if A is false and B is false, neither of them are true, so neither of A or B are true, so that's the only outcome where you get a false as your answer, because in the other 3, at least one of them is true. There's another one called the AND logical statement. If A is true and B is true, then the outcome is true. So if we look, in the first case, both A and B are true, so this should result in true, and the other 3 cases won't result in that. So there's an AND function, equals and it compares 2 things, A and B. If they're both true, it results in a true value. Otherwise, if I drag this down, it results in false values. Now you can actually do more than 2. We can have a C letter here, which we'll do in a minute. And all 3 would have to be true in that AND statement for the result to be true. There's another function called the not function, not A. And that just returns the opposite of these values. So not A, sometimes you see the little squiggly mark as not. Sometimes there's a line above the A to denote that it's not A. And again, there's a function called not in here. So the not basically gives the opposite of what is in the cell you're highlighting. So the opposite of true is true. The opposite of true is false. The opposite of true is false. The opposite of false is true. So it just basically inverts it and does the opposite. So that's the not function. So if we wanted to know, say for instance, what if we do not A and B? So we want to know if A is not true and B is true. If that's the case, we should get a true value here. So I'm going to say if not A is true and B. Well, there's no place to put B right now because I need to put my AND statement on the outside. So we're ANDing A and B together, but we're ANDing the not version, the inverse version of A. So if not A is true and B is true, the only case that this happens is right here. If we take not A is right there and B is right here, I realized I just made the mistake. I could see I chose, you probably saw it before me, I chose the cell B4 instead of B5. So let me try this again. Start it up here. That makes more sense. So not A and B. Okay, let's take a look at that. So not A, that's false, and B is true. Both of them have to be true for the AND function to output a true. So the only place we see that it's true is when not A is true and B is true. Those are the only 2 places. So this is the function not A and B. We get false, false, true, false. All right. Let's try to complicate this a little bit more and add a third variable. Okay. So I'm going to erase, actually I'll start a new sheet. And I'm going to label this A, B, and C. And so A is going to be true, 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 false, 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 false. There's going to be 8 cases here. True, true, and then true, oops, put the false statements in. So we're going to have 8 possible outcomes. True, false, drag it down. True, false, true, false, true, false, true, true, false, false, true, true, false, false, and then the rest. So there's no single line that has the same exact values. there's 8 possibilities here if you look at this closely. So what I want to look at is, what if we want to know what A and B or C? A and B or C. So what we're going to do is type that in. So we're going to do A and B first, equals and A, oops, A is here, comma B. If those are true, or C is true. So A and B are both have to be true, or just C. And so we have to put an or statement that surrounds the whole thing. These two have to both be true, or C has to be true. So either both of those or just C. Or all the combination can be also the case. So we can see all of these are true here. So the output will definitely be true. In this case, A and B are true. And so even though C is false, you still get a true output because A and B are both true. So one or the other. So if you go through these, you can see sometimes it's false, sometimes it's true. If we look at this case here, A and B, one is false and one is true. So A and B is false because they would both have to be true for the and statement to be true. And since C is false, it turns out none of them work. Let's try one more. How about A or B and not C? A, oops. A or B and not C. Now you might be wondering, you can look at this two ways. Is it A or B and C? Or do you look at it as A or B and not C? You know, you can look at it one of two ways. So we need parentheses around one of these to be specific. And we're going to put parentheses around the A or B. So it could be A or B, but it has to also include not C in there. So that's what I'm going to do. I'm going to type in the or statement, or A, comma B, all right, so those two, and not C. So we're anding this statement with not C. So I'm going to put the and around the entire thing, comma, not C. And so you have to make sure you have the right number of parentheses. For every open parenthesis, you have to have a closed parenthesis. And so let's look at this first one. A or B. Well, that's true. A or B is that would result in a true value. But it has to be anded with not C. Well, not C would be false. The opposite of true is false. So even though these result in a true, this will be a false, and so that's why you get an overall false. So let's look at one more here. Let's look at this one right here. A or B. One of them is true. So that results in a true value. And not C is false. Well, it's false, but not C is true, the opposite. So we have a true in this case and a true in this case, and that's why it results in a true. So you get a true for A or B and a true for not C, and so that's why it results in that one right there. So hopefully you can use this in some of your homework assignments. This is pretty useful when you're trying to make truth tables using and, or, and not functions. So good luck, and thank you for listening.